أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان صدق الله العليم.
Thank you, sir. So next I request our head of the department, Dr. M. Jamamu Jafar sir, to deliver welcome address and the introduction of the resource person for this session. Good morning, everyone. It is a pleasant good morning from the Department of Physics, Jamal Muhammad College, and we take the opportunity to thank Almighty for the successful organization of this program. Today program on online faculty development program on astronomical studies under DBT Star College scheme in coordination and in collaboration with the SIGRU Collab, which is an Astro Lab, and the Center for Astronomical Studies in Bangalore. And of course, I take this opportunity to welcome everyone and our, especially our resource person, Dr. T V Venkateswaran, scientist of Vigyan, Prasad, Department of Science and Technology, Government of India. Sir, we welcome you on behalf of our physics department, sir. Thank you, sir. And we are having 5 resource persons for this particular program. Dr. T V Venkateswaran, and next session will be handled by Dr. Priya Hassan, Assistant Professor, Department of Physics, Maulana Azad National Urdu University, Hyderabad, and she is a co-chair, Working Group of Women in Astronomy, International Astronomical Union. And tomorrow we are having 3 resource persons. First session will be handled by Dr. T.B. Dinesh, Director, Servolarts, Bangalore. And second session will be held by Mr. Ramaseshan, who is the Head in Research and Development Section, SIGRU Collab, Bangalore. And final session will be handled by Mr. Ramasamy Venugopal, who is the Head Operations, Office of Astronomy for Development, International Astronomical Union. So we are having 5 great gentlemen for this program. They are going to handle different topics. And of course, I want to introduce some information about SIGRU Collab, with whom we are having a memorandum of understanding. And of course, SIGRU Collab is a startup working in the intersection of space science and technology. And they are working for schools and higher education institutions to establish space lab and astro lab in order to inculcate the idea of space education and research. And of course, they are running citizen science program for students, and such as asteroid detection, exoplanet studies, stellar astronomy, and astronomy data, and all these things. Actually, we are having a group of students working in this, and we are having an astronomy club, Vainu Babu Astronomy Club in our department, and we are having a telescope, Celestron telescope, whose magnification factor is higher than the telescope in our Tamil Nadu Science Center, Anna Planetarium in Tiruchirappalli. And we are regularly we are arranging for sky watches for our students, and we are having nearly 5 adapted villages, and we are having schools in that, government schools there, and we are getting this telescope to the particular places, and we are running shows, that is night sky watch programs we are running for the village people. And of course, with the collaboration of the planetarium people, courtesy to, I think that they are in this in the link they are right now. I take this opportunity to welcome the people who are always having a helping hand and sharing responsibility personalities, like Mr. Agilan, Director Planetarium Tamil Nadu Science Center, Anna Planetarium Tiruchirappalli, and Jayapal sir, who worked there, and now he is under retirement. And of course, he is a helping personality till this date. And one student fellow who is there in St. Joseph's College. Of course, he is having a sparing hand for us every time. And what's that? Next, Jayapal, and of course, a great gentleman, Mr. Bala, who is the secretary and correspondent of a school he is running here in Tiruchirappalli. And that gentleman, he is the president of Trichy Astro Club. And Manoharan sir, who is a bank employee, of course, he is in Tamil Nadu Science Forum. So all the people, they are sharing our responsibilities, and they are extending a warm and cordial help towards us in this particular space venture. Of course, SIGRU has actually, the job of SIGRU is to get the information from a US-based International Astronomical Union, and they are getting so many database from them, and they are analyzing that. And SIGRU has detected so far 4 asteroids. The names are, of course, they are given, and they are listed in the main belt asteroids database of Minor Planet Center, International Astronomical Union. It is really a great achievement. And of course, the Bala sir and Muhilan team, they have identified some 2 asteroids, but of course, it is in the preliminary study, I think so. They are waiting for the approval from NASA. And this SIGRU people, they are having collaboration with various international and national organizations in astronomical education and research, especially International Astronomical Search Collaboration, Space Generation Advisory Council, Open Space Foundation, etc. Of course, in this, we have to mention 2 great gentlemen. One, Mr. Surendra, who is the project director there in SIGRU Collab, Bangalore. Of course, we feel proud to introduce him as our proud alumnus. He is a proud product of Jamal Muhammad College, and he got 2 Young Scientist Awards from from the hands of the former President Abdul Kalam sir. And of course, he is blessed with this, and he had a Midas touch with the hands of golden hands of our Abdul Kalam sir. And one more person, Rama session. Of course, he is going to be a resource person in the tomorrow session, and that gentleman is the head for the research and development section. These 2 people, just they are sparing a helping hand towards us, and we are planning of so many programs, and we are planning of starting a small center, astronomical center in Jamal Muhammad College soon after the examination. That is by next week, where they are going to have a training program in Bangalore. The selected students are going to be given a week program on the basic information regarding that. Already the students who are having basic tinge with astronomy interest, as well as the computer software packages and all these things, those people will be given training for 1 week. And then after that, they will be coming here to our college, and they will be running a section of it. They will be getting some data from the Open Space Foundation. Of course, they will be getting the data, and they will be analyzing it. If there is any possibility for identifying any new planets, exoplanets, that is exoplanet. Of course, all the information you will be getting in the lecture session. And of course, we plan for it. Soon they will be having the exposure in this particular work. So with this SIGRU collab, Surendra and Ram, these 2 people, they are sparing so much helping hands towards us. Thanks for that, those 2 people. And of course, they have identified the resource persons, because we didn't have the opportunity of identifying such great eminent personalities like Dr. T V Venkateswaran and Priya Hassan and T V Dinesh and Ramasamy Venugopal. All these people, of course, we don't know. The thing is, they have arranged. Of course, these 2 days program will be so informative, and it will be so useful. I assure that every information spared by them will be really an eye opener for everyone who are having that basic tinge of astronomical exposure. Of course, I take this opportunity to welcome Dr. T V Venkateswaran and the remaining people for this program, and the basic job of introducing the T V Venkateswaran sir. He is the scientist here in Vigyan Prasad, Department of Science and Technology, Government of India, and he had his PhD degree, and he is having a PG diploma in Science and Technology Communication. And of course, he is the head for audio visual section, and he has developed so many programs for generation of audio software and production of audio science serial. Of course, he is a man with behind audio science programs for World Space Radio, All India Radio, and Beyond Warning. He has catalyzed and produced so many popular science video programs, and he has created minimum facility for audio video production of science communication multimedia software such as PPT shows and CD-ROMs, etc. And he has developed so many academic programs and research in the area of history of popular science and science and media. The session to Dr. T V Venkateswaran sir, scientist of in the among our participants. Of course, we are participants 417. So we are having nearly 417 participants in this program, and of course there is a mad rush for this program. Only just 2 days back that we have given in the open intro, and of course within 2 days just we got all these people, and so many people they are inquiring about it, and we are having a warm response from so many sectors of the people. I hope that the following sessions will be so fruitful for the people, and hoping that everything will go good. Thank you once again, and once again I welcome all the participants, and please spare your ears and mind towards these programs so that it will be really an eye-opener for everyone towards this astronomical exposure. Thank you. And if you, the participants, if you have any doubt, means don't hesitate to contact Jamal Muhammad College. We are by 24/7 into 365. We are at your service, so you can have.
Thank you. Am I fine? Space science, quite obviously, is very enchanting, and a lot of developments are exploration of space. But that today there is a new branch within the medical sciences called as robotic surgery. You know, where the surgeon uses robotic machines to do surgery. This whole technology was developed from the space sciences. In fact, when you are the space shuttle and dock to a spacecraft in the space, you needed certain robotic maneuvers. So technology, software, which for just a point to talk about is that I mean, few days ago there was an unknown So if you look at, please mute at your end, please. Thank you. So if you look at the plans, number of countries are planning to launch mission to moon. Of course, the chief 4 countries are United States, India, China, Russia. But in addition to this, there are also many private players who are planning to launch mission to moon. India has now proposed that the Chandrayaan 3 will be launched. Already instruments which are supposed to go in the Chandrayaan-3 lander has been tested. So the ISRO has announced that it is ready, and then it has also selected the paths. I mean, the rover substitute. Uh, okay, so this is a movement space, maybe occupy moon or other planets, right? So establish permanent places where people will start living. Maybe human habitations will emerge and so on. The US plan, US has made a plan whereby they are saying that we will take back humans once again. All other missions, whether it is Chinese mission or Indian mission or Russian mission, they are all robotic missions. Basically, meaning that they are not going to take human being to moon. But the program of US, they are saying that we will take back humans back to moon, and they say that it will be a first step towards establishing a lunar colony. That's what is the NASA plan. Of course, the details are yet to emerge, but broadly the plan has been put into public domain. So the idea is to put in a lunar colony. Okay, so let's go. If you look at human being, the one of the key essence of human being is migration. We may think that we are rooted, we are attached to our place of birth, and so on. As individuals, we might be attached to our place of birth, but as a species, we have been moving around. Modern human being, or Homo sapiens sapien, we emerged somewhere around 150,000 years ago in Africa, what today is part of Congo. Okay, and from that place, the human population started to spread all around the world. And then in India, the modern human population came in somewhere around 80,000 years ago. Okay. So in Indian subcontinent, modern human being is maybe about 60, 40,000, 80,000 years ago, right? So similarly, rest of the world also, there was migration of modern human being. In fact, one of the latest migration, I mean, in terms of founding population, if you look at places like New Zealand or some of the islands in Pacific, they are just about 2,000, 3,000 years ago. Okay? Even in Africa, it's not very old. I mean, in some parts of Africa, the human migration took place about 3,000, 4,000 years ago, 5,000 years ago. Okay. So, traveling, going to new places, exploring new things, okay, has been one of the key aspect of human civilization. This did not stop with the earliest human migration, but also continued during historical times. We have heard of Alexander trying to go to different places, right? Similarly, we have heard of Chinese travelers, right? Similarly, from India, there has been travel to other parts of the world, right? Okay, so this kind of exploration has been one of the key aspects of humanist. So we should look at the space exploration as a natural next step. That is why Konstantin Tsiolkovsky, who is considered as the founder of space sciences or rocketry or space exploration, he famously said a Russian thinker, scientist who developed the what is called as the rocket formula and all that. Okay, so he famously said, "The Earth is the cradle of humanity, but mankind cannot stay in the cradle forever. When we are born, we are put in a cradle. That's how where we grow, right? But you don't stay in the cradle all your life, right? So if you look at humanity, not one single human. About once upon a time, it was the Congo region of Africa. Not stay there, right? We moved out. In the same way, human being, we are naturally to move into space, right? So the Earth is not Earth is the cradle. It's our mothership, but we cannot just stay there alone. So that's how he brought in this whole vision of space exploration, human beings living in space, into the modern scientific grounding. Yes, there were even earlier people talking about fantasy literature, talks about human being traveling to other worlds and so on. Okay, whether it is in China or whether it is in India, there are a lot of mythologies, mythical stories like that, fantasy stories like that. But they were not based on science. They were all essentially based on some kind of a visit and coming back. But here is a thought that is talking about human being migrating to new places. So backed up by his work on rocketry. How so? In a sense, you can say the scientific of space exploration began with Constantine Prasad. That's why he is called as father. The actual birth of space age, there were theories. The actual birth of space age emerged from the launch of Sputnik 1. Number 4, in 1957. The first flight into space, putting an object which goes on artificial satellite, Sputnik. Okay. On October 7th, 1959, same year, the Luna 3 went and circled the moon, so became the first artificial satellite for moon, and then took photograph from the other side. I'm sure you all know that from Earth, we can see only one side of the moon, the far side of the moon, the other side of the lunar surface. Till then, all the lunar missions were crash landing, meaning that it will just go and crash. Like say, for example, India's Mars impactor mission, which was there in Chandrayaan 1, was a crash lander. It just went and crashed. Okay, so similarly, all these missions to moon were largely crash landers, or which went around the moon, took in orbit for quite a long time. You wanted to study many of these things. So Soviet Union was the first to launch a space station. Salyut 7 was this space station, and it functioned from 1982 to 1991. Okay, Salyut 7 was one of the earliest space station to function in the space, and Rakesh Sharma, the first Indian, or the only Indian as of now, to go to space went in this space station, went to the space station. Okay. Yeah. So then came the Mir, yeah, second space station established by Soviet Union. So it was launched around 1989, and it functioned up to 1999. That is roughly 3,644 days. And all through this 3,644 days, there was continuous human presence in the space. Okay. So Mir space station was launched in 1986. It functioned up to 2001. Okay. And roughly about 100 space travelers from dozen countries, including India, France, Germany, Japan, they all went to this space station, Mir. Okay, so this expanded Mir space station, Soviet space station, also provided a ground for testing human beings. So during this time, from 89 to 1999, there was a continuous human presence. Something like, say, for example, today in Antarctica, there are stations where there is continuous human presence, right? So in the same way, there was a continuous human presence in the space through this space station. Then came the US Skylab, which functioned between 1973 and 74. Okay, so it was there only for about 24 weeks, occupied by, that's about for 2 years, occupied by human being. And then China also joined this space station. So it established in 2011, which was operational till 2018, and then the second one was launched in 2016. It was operational till 2019. The International Space Station, okay, sorry, the China is launching another major space station that's going to be launched. The core module was launched in 2021. Slowly they are building. In next few years they will build the Chinese space station, okay, which will have about 60 ton. Okay, it will be less than the Mir space station, but still a substantial space station that they are planning to build in space. So if you look at the International Space Station, which is the most famous one, most of us know about this. This was put into operation on 2nd November 2000. From then on till today, there has been at least one human being in the International Space Station. So you can say that from 2nd November 2000, for almost 20-21 years, there has been continuous presence of human being in the space. So today, people say that space is the 8th continent. There are 7 continents. That's what we kind of classify the landmass on Earth, right? So now the geographers are saying that we should now consider space as the 8th continent, particularly low Earth orbit space, not the deep space. Because if you look at the low Earth orbit space, we have been present there for more than 20 years. And if you include other space stations which were there before International Space Station, so something like about 25 years of continuous stay in space has been kind of achieved, right? Of course with break, but 20 years without break, 20-21 years without break, right? So this is what is the current scenario. What was happening on this space stations? I talked about launching to moon, reaching a nearby space object. Okay, moon is the nearest stellar object. Okay, so we were sending a human being, we were sending robotic missions. Parallelly, the space stations were being built and then space stations were being tested. So what was happening? If you want to go to Mars, for example, it's going to take a long time. The mission to Mars will have to be at least 6 months. 6 months will be like rushed one. You just land on Mars, spend few days and then come back. Okay, so the minimal time that will be required for a mission to Mars will be about 6 months. How do you sustain human being for 6 months? What are all the challenges that you will get if a human being is in space for 6 months? You need to know it before you plan a space visit to Mars, right? So that's what was happening in this space stations. Okay, we gathered experience, we gathered medical data, so on and so forth. Okay, so many things were happening. While this was happening, there was also deep space exploration by spending spacecraft to other stellar objects. I mean, other space objects, not stellar objects. I'm sorry, space objects. Like you had Voyager 1 launched in 1977, which made visit to many of the planets. Similarly, you had Voyager 2, which was launched around the same time, okay, which also visited a number of planets, right? So these are all called as flyby missions. Flyby mission meaning that it won't land or go in an orbit around a planet, but it will go very near the planet, so that by using a camera, you can take very detailed picture of those planets. You can collect scientific data, and we can know much more about those planets than from using just mere telescope. Okay, so if you include New Horizon, one of the recent deep space mission, we have visited almost all the planets and dwarf planets in the solar system. Right, so this has happened, and today, if you look at the Voyager 1 and Voyager 2, they have left the solar system into deep space, okay, interstellar space. Right, so today our space exploration is not just near Earth or only to Moon, but our object has gone beyond the solar system into interstellar space. Classல இருக்கேம்மா, கிளாஸ் எடுத்துட்டு இருக்கேன். Yeah. So while these were all happening, there were some more studies that were being conducted on Earth. What are these studies? These studies are, how do you ensure that you will be able to develop recycling technologies? And then what are all the challenges when a small group of human beings are stuck in one place? If you want to go to Mars, I said that it's a minimal 6-month journey, right? But practically speaking, it will be a bit more than that, because when you want to go to Mars, you don't want to spend only a few days. You want to spend at least a few months, right? So which will mean that about 9 months to a year. That's what will be the human program. Of course, the initial programs might be like very short. When you go there, and can you please mute whoever has switched on your mic? Can you please mute? So you will have, you may have only a very few days stay on Mars, but over a period of time, when you want to send a human being to space, then you want to have a longer duration space journeys. Only then it will make sense. Okay. Of course, Moon is a different thing. Moon, you can have a space mission which is about a week or 10 days. But when you're talking about long distance, like, I mean, even the nearest planet like Mars, it is like 9 months or so, 10 months or so. Okay. 6 to 10 months. Okay. Remember, Mangalyaan took 10 months to reach the Mars. Okay, right? So, given all these things, how do you ensure that you will have enough supplies? Okay. So, yeah, experimental simulator, Mars simulator, it was called as Mars simulator. It's called BIOS. BIOS 3 was set up in Soviet Union in 1972. So basically, it was like a sealed room where almost nothing will go from inside and nothing will come out from that sealed room, except maybe if you want to throw away some excreta or something, you throw away, but otherwise nothing will new go inside. So it will carry some amount of water. That water will be recycled and so on. Okay. So in this simulator, they were able to develop a technology whereby for 3 people, roughly 95% of the water needed would be recycled. Okay. So they were able to grow their own food, harvest their own food. Okay. So these were all called as simulators, where volunteers were kept inside this chamber for a long time to test whether you will be able to do sustain space travel. One of the latest study on this is what is called as the Mars 500 program. Okay, actually it was 520 days they stayed there. So it was again a simulator like this, which was capsules which were constructed. So in this capsule from 2007 to 2011, this study continued. There were different bunkers or different capsules in this whole thing. So one area was like while you are traveling in the space. The other area is while you are in the surface of Mars. Okay, so the condition in space capsules will be different from the condition in Mars. Okay, so to see that whether you are able to sustain. So basically the idea was that suppose if you are doing an outward journey from Earth to Mars, roughly it is going to take you 250 days. And suppose you are spending about a month, that is 30 days on the surface of Mars, and then a return journey of 240 days. So total roughly about 500 days. If that is so, then what is the challenges? Okay. So basically there were about 6 crews, 3 Russians, 1 Chinese, 1 French, 1 Italian, was sealed inside this compartment, and then the test was done. Okay, so they were able to test whether they were able to psychological impact of keeping a small number of people confined in a space. Okay, and then basically whether they were able to grow their food, whether they were able to maintain themselves, whether water recycling, air recycling, etc., could be done, and so on and so forth. Okay, so this study was conducted in the Soviet Union. Russia. When it started in Soviet Union, but in Russia right now it was conducted. In fact, the next level of this simulator is under construction, and they are going to start this experiment very soon. In fact, one Indian has been given an offer that if he wants, he can join this, but then he requires a huge amount of money. I don't know what happened later. So initially he was in contact with me. But anyhow, let's see. It's going to take some time before, COVID situation, only when it ends, they will start, because they will not be able to put people inside, and they get COVID, then it will be a big trouble, right? So they'll start only a bit later. But yeah, so these kinds of studies are also parallelly going on. So if you look at this simulator, inside it, you are actually growing vegetables, growing food, using your excreta to fertilize the soil and so forth. Okay, so these were the kind of experiments that they were able to do. They were able to see what kind of challenges occurs, because you have to bring in a proper technology before you can actually plan for this deep space travel, right? A similar attempt was made in US called as Biosphere Project. It started in 1994, and prematurely they had to end in 1994 within few months, basically because there were a lot of huge legal challenges, and then some cases came in. Many other such issues came in. From that, they had to completely shut down this Biosphere 2. So in the Biosphere, basically it was looking at 2 aspects actually. It was not only space travel. At the same time, it was also asking questions like, how do you build a sustainable world? Today we know that there is climate change, right? So climate change challenges. So we also need to build economies which will be like recycled economy, right? So how do you build that? That kind of questions were also asking. In fact, as I pointed out when I started this lecture today, that robotic surgery came from technologies which were developed for docking space capsules, right? You know, how to attach one space capsule with another and so on and so forth. In the same way, some of these studies of deep space travel are expected to give us insights into how to manage our production economy and sustenance on Earth so that we don't pollute it. Okay, once you recycle, we will not be damaging Earth systems, right? So how do you manage Earth systems? We think that that kind of insight will come from these studies. Okay, yeah. So these are all things that was happening from the birth of space age to today. But let's look at the lunar rush, travel to moon, right? So if you look at this chart, it is talking about space launches by different countries like United States, Soviet Union, or today it's Russia, Japan, European Space Agencies, China, India, others. Okay. So if you look at the early phase, that is between 1960 and 1975, you see only two colors, US and Soviet Union. And very interestingly, somewhere around 1975, 1976, the missions to moon stops. Nobody is sending. There is a complete blank. Nobody is sending any mission to moon. And suddenly, 1990s, there is an interest. Japan, for example, starts to explore. US again starts its program. China starts. India starts. Okay. And then you suddenly find that from around 2005, there are number of missions. Missions are growing. Okay. Many countries are trying to send spacecraft to moon again. So that is why I am calling this as a second honeymoon. There was an initial honeymoon with the moon. We try to go to moon, and then we kind of stop, kind of laid back attitude for some time. And then again, there is a interest to go to moon. Now the interest is not only from government agencies, but also private agencies. Private agencies are also trying to send spacecraft to moon. For example, the Israel mission was by a private company. Similarly, the Luxembourg effort was by a consortium of private companies. Number of private companies, even from India, one private company is trying to send a mission to moon. Okay, right? So there are a number of countries which have been doing. Okay, so if you look at the number of missions that have occurred till now to moon, you have US with about 30, USSR, that is Soviet Union with about 23, China about 8, Japan 2, EU 1, India 2, Luxembourg 1, and there is a failed mission of Israel and so on. Okay, so this is the current situation about successful missions, right? So if you are looking at the future plans, okay, the plans for mission to moon, okay, you from 2020, you have the Chinese robotic mission lander, return mission lander, which is successful. Okay, then future missions, if you look at, number of countries are planned to go to moon. Not only institutional, meaning that ISRO, NASA, or Chinese space agencies, but also commercial. Okay, commercial companies are also planning to send a mission to moon. Okay, so a lot of missions are being planned today. Okay, many of them are return missions, meaning that it will land, collect solar sample, and then bring back. Many of them are orbiters, some of them are landers, some of them are with mobility. And one of the mission, the US mission, is with human. Okay, so this is the second race to moon. Okay, so the race to moon has again started, called, which I'm kind of calling it a second honeymoon. So if you look at the NASA plan, NASA is planning Artemis, which is a human mission to moon. They say that this whole plan is not just send one human being and come back, but slowly, step by step, build a lunar station so that permanently people can stay there. And then what will this lunar station do? It will explore moon for its minerals, do radio astronomy, telescope astronomy from the surface of moon. Okay, so it is looking at both the fundamental science research and also commercial utility. Okay, so that's what is the plan thought of. Okay, so it is supposed to go step by step, and then by 24 they were supposed to land on moon, but of course now with COVID things are changed. So all of them are reworking. So they are waiting for the COVID to be over to rework. Okay, so but that's the idea. Okay, so step by step, the idea of NASA is to place human being and then build a space station. Same way China. China has done a robotic return mission, meaning that it landed on moon, collected moon samples and then brought back to Earth. Future, they are planning to send more missions. Okay, so number of missions including landing on moon, exploring the surface of moon, return missions with collecting samples and bringing back and so on. So this is what the missions they are looking at. Many possibilities come when you land on moon today, which was not available in 1960s or 70s because of absence of technology. Okay, with the modern technology today, there are many possibilities. One, we can use some of the craters of the moon as a radio telescope dish. So you can do a much better radio telescope astronomy from the surface of moon compared to Earth. Okay, you don't have to build a dish antenna. You can use the crater itself as an antenna. I mean, you can lay the mesh on the surface of the crater and then build a huge radio telescope on the moon, which will have much better view, much better sensitivity. Similarly, if you want to do interplanetary exploration, like you want to go to Mars or other planets, right? If you build a space station, launch station on the moon, and some or other, if you can build fuel from the surface of the moon, from the material available in the moon, which we can, I will explore you, then your space launch cost will come down substantially. Okay, so people are thinking that why don't we put a spaceport on the moon? Spaceport from the moon. Okay, so like you catch a train, go to the airport and then catch the flight, right? So in the same way, you will catch a shuttle and you will go to the moon and then catch the space probes, okay, which will travel long distance, right? So that's what people are working on. So these are all some of the ideas that. So why there is a rush to moon now? That is to do with something called as a lunar gold rush. When I say lunar gold rush, I don't mean actually that they are planning to take gold from moon, but a gold-like substance from moon, which is rare earth minerals. Okay, so the moon is flushed with number of materials. Okay, water. Earlier, we never knew that moon had water. Chandrayaan-1, particularly it's a moon impactor probe, for the first time brought to light that there is a good amount of water on the surface of moon. Okay, as moisture and other material. Okay, so water is a very important component. Moon seems to have it. Okay, so you can use it to create fuel. Okay, if you disassociate water, then you get oxygen and hydrogen. So oxygen and hydrogen can become a rocket fuel. For example, cryogenic fuel are basically oxygen and hydrogen, right? So you can use the water to create fuel on the surface of moon and then fuel your rockets. Gold is there, fine, but more important, there are rare earth elements. Today, any electronic material, whether it is a mobile phone, computers, or whatever it is, they use number of rare earth materials. Okay, they are rare earth because it's rare on the surface of Earth. It's not easy. One of the rare earth material, or one of the important material on the surface of moon is called as helium-3. I'm sure you would have read in newspapers, in news stories, in the recent past when people were talking about China has created an artificial sun. That's how usually the titles were there. Okay. So actually what it is, there is a international collaborative research taking place in France that is called as ITER, International Thermonuclear Energy Test Program. Okay, it's called short form as ITER. It's a French name. In this in this international experiment, India is a partner, China is a partner, so is Russia, European Union, USA. Many countries are partner in this. Almost about 20 countries are partner in this program. Each of this country is supposed to develop one aspect of that international collaboration. In India, we are developing what is called as cryogenic parts. Okay, cryo shield and things of that kind are being developed. There is an institute in Gujarat called Institute for Plasma Physics where this work is taking place. China is developing some components, and part of it is one of the nuclear reactor called as tokamak. Okay, so they have built a tokamak where they have been able to sustain million-degree temperature for a quite long time. Plasma for a quite long time. It's a major challenge. Okay, so all these technologies are being developed to build this thermonuclear reactor in France, experimental thermonuclear reactor in France. So if we succeed, and people say that we will succeed by 2030, this is supposed to produce commercial level power. If we succeed, then we will be using the same process that is happening on sun to produce electricity, nuclear fusion. In the nuclear reactors, we use the process called nuclear fission. We are breaking heavy elements like uranium. But whereas in your nuclear fusion, you will be combining lighter elements. And one of the best fuel for this kind of a thermonuclear reaction is helium-3. Moon is abundant with helium-3. I don't know how many of you have seen this new web series that's on the air, Sony Live, called Rocket Boys. So in one of the episodes, there is a dramatic scene where Homi Baba brings in two big lorries full of coal, and from his pocket takes a small few kilogram pellet and says that whatever energy the two trucks of coal can give, this pellet can give. And he is talking about nuclear fission because it contains uranium. That pellet contained uranium. That small piece of rock contains uranium. So now you can keep those two trucks. You can keep the small pebble in your hand, and then in your another hand you can keep a small like a mustard seed. That's the mustard seed amount of helium-3 can produce so much of energy, right? So if we can mine the moon, collect this helium-3, if you bring back to Earth, then it can become, it can fuel your future thermonuclear reactions. Unlike coal, which you need in bulk quantities, helium-3 you need only small amount, few kilograms, to maintain your power stations for years, for months, I mean, which then is possible, right? So that is why today, if you look at the technology that people are developing, they are developing to land on the surface of moon, move here and there, so that you can find out where actually helium-3 is available. So you need technology to find the helium-3, map it, mine it, put it back in a canister, and return it back to Earth. So if you look at, for example, the Chinese sample return mission, that's a kind of technology that we will be using to mine moon, bring back helium-3. Okay, so this is the dream, right? So of course there are lots of challenges, but that's the idea that people are working on. So can we use moon's natural resources like helium-3 or rare earth elements, which is there is a huge shortage on Earth. Okay, so can we use? That's the dream that is driving the second honeymoon. That's why commercial companies are interested. So it's not only basic science, but also commercial interests are driving this second honeymoon. Okay, so this is called as space gold mining. So it's not only on moon, but you can also do similar thing on asteroids. Okay, so asteroids are also rich in these kind of materials. So people are saying that we can try to bring in some of the rare earth elements and precious elements from these objects. Okay, from asteroids and so on. Uh, Platinum, for example, is used in catalytic converters. You know, if you have a scooter, there is a small amount of platinum in your scooter, right? But it's a small amount, but that's very, very hard to get. So, can we mine asteroid and bring back platinum, for example? These are all the kind of questions that people are asking, and that's how the second, with the current interest in space exploration is driven by this such dreams. With the development of robots, with the development of artificial intelligence, machine learning, now new technologies are available whereby you can actually do this kind of. I'm sure you have read that recently US has launched a spacecraft which is supposed to change the direction of a small space rock as an experimental method. So the same technology can be made to bring the asteroids near to Earth so that you can mine, for example. Okay, so various such possibilities exist. This is what is driving the current research. Okay, so the commercial interest is one major thing that is going on. What I'll do is that I think I have now taken up to 10:40. I think maybe it's time for me to stop and then go for question answers so that the next session can begin right at time, right? So I think my session is up to 11. Am I correct? I mean, or do I have time? Organizer, can you kindly inform me?
Yes, sir. So we have time. So we scheduled up to 11:30. We can start the conversation if you're okay. Yeah.
Yeah. Okay. So then I'll continue and I want to share some ideas so that I'll share and then we'll go. Okay. So that's
Sure.
a good idea.
Yeah.
Okay. Yeah, sure.
Thanks.
Thank you. Thank you for confirming. So let me carry on. Okay. So now I'm going to bring you to another aspect. Okay. In this space interest, there is another important aspect for all of us. Every citizen of this world, to consider. There is something called as a Antarctic Treaty. What is this Antarctic Treaty? This Antarctic Treaty is, I mean, for example, Antarctica had no human being. Okay, it is so cold that no human being existed in Antarctica. So when Antarctica was found, the question came that to whom this Antarctica landmass belongs. So there was a huge international debate and so on and so forth. And finally, there was an Antarctic Treaty that was established, which divided Antarctica like a cake, okay, cut into pieces, and said that this part of Antarctica is belonging to this country and so on. Thankfully, by that time, India had a station in Antarctica. Okay, so we also had got some rights over Antarctica. So if you look at Antarctica, Norway is in northern hemisphere. Antarctica is in southern hemisphere. But Norway gets a area for itself. How come? Because Norway had marine ships which can go to Antarctica. They were able to establish in a station on Antarctica, and from that, Norway claimed that part of Antarctica should belong to it. Okay, so of course there is a still a debate in the international community. Some countries don't accept each other's claim. Brazil, for example, or Argentina, for example, says that Argentina is almost touching Antarctica. So that part of Antarctica is basically like extension of Argentina, and so it should belong to Argentina and so on. Okay, so there are some debates, but what we see here in Antarctica Treaty is that Antarctica is made into sovereign areas of different countries. Okay, but then there is also something called as law of the high seas. Okay, so there is something called as the United Nations Convention on Law of the Sea. Suppose, let's say you go in a ship, you go into high seas. High sea essentially means that when you cross 12 nautical mile from the shore, okay, so when you cross that border, okay, that 12 nautical mile, okay, so you are into what is called as high sea or international waters. Who that international water belongs to whom? It does not belong to anyone and it belongs to everyone. Meaning that to go to that international water, you don't need permission from any country. Anyone can go. Whether you are from India or US or Norway or from Congo. Congo does not have any share of Antarctica. Please remember, Norway has. Congo does not. Why? Congo was a colonial country, it was a backward country, it did not develop technology, so it did not get anything. But Norway, because it was a colonial country, it robbed riches from third world countries, and it had money power and technology power. It gets a portion of Antarctica, even though Norway is in northern hemisphere. I just picked up Norway as an example. You can look at other countries too. Okay, so if you look at, for example, UK, Britain as a space, okay, France as a space. Why? Right? So these are all questions that is there about the Antarctica Treaty. But when you come to international waters, so if you look at this blue region, not the green regions, light green regions belong to, they are called as national waters. Okay, so up to 12 nautical miles, it's called national waters, and beyond that is international waters. So if you look at the international water, it does not belong to anyone, but it belongs to everyone. Okay, so that's the international water. Here, the property is common property, not private property. Okay. So now, what happens to moon? When the Soviet Union landed on moon, it carried the Soviet flag. Not only that, after it landed, there was a kind of a spring mechanism through which it threw a large number of Soviet flag on the surface of moon. So there was a huge international debate in those days. In international law, suppose if there is an island which nobody has gone till today, okay, or an island comes up, okay, sometimes islands do come up, okay, because of geological processes. Whichever country goes there and then plants its flag, that island belongs to that country. That is the international law. That's called as finders keepers. That is, those who found will keep it. So if you apply the same law to moon, then the Soviet Union could have claimed that the moon belongs to them because they reached there first, they put the flag first, and so on. Okay, so there was an international debate and so on. Soviet Union said that we are not claiming moon as our own. Okay, so this is a spacecraft which carried the flags, and then these flags and symbols of Soviet Union was put on the surface of moon. Okay, so this created huge debate. So the America said that let's do an international treaty. So in 1967, January 27, outer space treaty was signed. Basically, it was initiated by America and Russia. That is not Russia, Soviet Union in that time. Okay, so it jointly put up this peace treaty, which many countries have today accepted, including India. Okay, so what does this treaty say? This treaty say the outer space, including moon and other celestial bodies, will be the province of all mankind. What does it mean? It means that it will be like high seas. It will not belong to anyone. Nobody can claim that it is my right. Okay, everybody can use it, everybody can go there, and so on. Okay, so and not only that, it says that because it's a common property, any exploration that you do in these places by whichever country, whether you are a powerful country, uh, country with money, and so on and so forth, whatever benefit that you get from that should benefit all humankind, not only your country. That is why when Soviet Union and America brought a soil sample, they distributed that soil sample to other countries which had capabilities to do research. Of course, they did not give anything to Congo because Congo did not have any research laboratory. But India had a research laboratory, so we got samples. Though we were not able to go to moon in those days. Okay. Similarly, it was given to many countries because of the same principle. The principle was that it should be benefit everybody, not just only those countries. Okay. So that's what the next one it says. Irrespective of their degree of economic or scientific development, all countries should get benefit out of space research. Right. So that was the idea. And then there should be freedom to do scientific investigation in any place. Right. So Antarctica, for example, Congo, suppose let's say wants to establish a station in Antarctica. Now Congo cannot establish because Congo does not have any land. Then it has to go and beg some countries which have land to permit it to conduct the experiment. But if Congo wants to go to moon, it can go because moon belongs to everyone, right? So this is the international law, that is a space treaty, which existed, which was established around that time. So it also says that the space objects will not be for any national appropriation, meaning that it should not be occupied, it should not be, nobody should claim any sovereignty on space objects. Okay, so this is a international law. Then came in 1979 what is called as a Moon Agreement. So this Moon Agreement says that in Moon there should be no international conflicts. That is meaning that you should not place any weapons for targeting other countries and so on and so forth on Moon. Okay, it should benefit all people. It should be used for a peaceful purpose and so on and so forth. Another treaty was signed in 1979. Okay, and it is based on this treaty that the Soviet Union said that because it was the only country at that time having a space station, that it will take cosmonauts from other countries. So people from, I mean, the cosmonaut from Afghanistan has gone to space. Okay, using the Soviet rocket. Okay, so Soviet Union said that respecting that international law, it will benefit all the humankind, and then took people from various countries, including French, German, Canadian. Okay, not only the developed countries but also underdeveloped countries like Afghanistan. Okay, they took the cosmonauts to space, and then they stayed in the Mir space station, and then came back like Rakesh Sharma, right? So this happened. This was called as Intercosmos. This program was called as Intercosmos. Okay, yeah. So according to this treaty, no nation can claim ownership on the moon. But if you want to, okay, now coming to the outer space treaty, okay, all countries in the green are party to it. All countries in blue, all signatories, meaning that they are also agreeing. Only the countries in red are not signed it. Okay, so the countries which in red are very small in numbers, so they have not signed it, but majority has signed it. But if you look at the Moon Treaty, there are only very few countries which have signed it. Not even America, not even Russia have signed it. Okay, India is a signatory. Okay, but most of the countries are non-parties. So which means the Moon Treaty is not in agreement. So the Moon Treaty is coming up for revision. So there is a international debate going on in revising the Moon Treaty. So if you want to revise the Moon Treaty, okay, so many countries think that the revised Moon Treaty will go in the direction of Antarctica Treaty, where it will be divided into zones. So to whom the division will go? Only to those countries which have power, which have capabilities, which have landed on Moon. Okay. I mean, if you have not even landed on Moon, if you have not even don't have a rocket to launch, okay, the countries may deny that you don't have any right on Moon. That is why many countries are now gearing up and wanting to reach Moon and place their flag. Okay, so in addition to the commercial interest that I talked about, like harnessing the rare earth elements and so on, there is also this international treaty which is shaping the way the space exploration, particularly to the Moon, is happening today. Okay, so who owns the land on the Moon is an important question that has emerged as a real question today. In 1960s, it was still a debate because there was only one or two mission in a year that can go to Moon. But today, with the technologies developing, with the robotic missions possible, right? So actually, in next few decades, the Moon can be really exploited. So this question of who owns the Moon, whether everybody on the Earth has a right over it, these kind of questions are important questions that have emerged before us. Okay, and this is where the space exploration stands today. Okay, I think with this I'll stop my lecture. I'll go for question and answers. Thank you.
Thank you, sir. Thank you very much, sir. So now floor is open for questions. Participants.
Dear participants, if you have any questions, you can ask our resource person or you share your questions in the chat box.
You can also check whether the YouTube some questions are there.
Those who are in YouTube, you may also ask your questions in.
Okay, if there is no question, we come to the formal vote of thanks.
என்ன வேணும் உங்களுக்கு பேப்பரா இருக்கு 51 தானே மேம்
Hello? Hello? Hello, yes? Uh, Thank you.
Sir, Segdaud sir,
Yeah,
can we,
yeah.
sir, thank you, DV sir. Just a minute, sir. Segdaud sir, can we go for a vote of thanks for this session?
Oh, yes. Okay. So I request Dr. A. Muhammad Salim sir, Associate Professor of our department, to propose a vote of thanks for this session. Good morning to all. So it is my pleasure to propose vote of thanks on behalf of our department. So first of all, I thank Almighty for blessings on this gathering. So next, I thank our secretary and correspondent, Dr. A.K. Khaja Najmuddin, for providing an opportunity to conduct this online faculty development program, jointly organized in collaboration in knowledge in astronomical studies. The next, I thank our treasurer, Haji M.J. Jamal Muhammad, assistant secretary, Dr. K. Abdul Samad, and member and honorary director, Dr. K. N. Abdul Qadir Nihal, for their kind support and constant encouragement to conduct this faculty development program. Next, I thank our principal, Dr. S. Ismail Mahidin, vice principal, Dr. A. Muhammad Ibrahim, and additional vice principal, Dr. M. Muhammad Shihabuddin, to motivate us to organize academic activities under DBT Star College scheme. So next, I thank the directors of hostel administration, Dr. K. N. Muhammad Fazil and Ms. J. Hajara Fatima, for their kind support. Next, I thank our resource person, Dr. T V Venkateswaran, scientist chef, Vigyan Prasad, Department of Science and Technology, India, who delivered an inaugural lecture on recent development in astronomical studies, higher education perspective. He shared information about mission to moon, the first footage of moon, Luna 16, and the space station. So it is highly informative to all the participants. The sir is also a mentor of the budding scientist. So as a parent, I have attended a school program. Sir gave a lecture to the school students, particularly the SRV school in Trichy. Is highly motivated to the school students who is taking the interest in the science subjects. Sir, I thank you very much, sir.
Sure.
I thank the head of the department, Dr. M. Jamal Muhammad Jafar, who delivered the welcome address and the introduction of the resource person of our head of the department took initiative for MOU with Chigru Collab with the help of Mr. Surender, our alumni, and presently being as a project director, Chigru Collab Bangalore, and Mr. Ramasesan, Head Research and Development, Chigru Collab, Bangalore. They are helping for us organizing this FTP on behalf of our department, and thank them. I thank the faculty members of our department and the faculty members from various institutions for their effective participation. I thank our department DVD coordinator, Dr. A. Ishaq Ahmed, and the staff in charge, Dr. S. Sheikh Dawood, for the effort to organize this FDP. So once again, I thank you all. So thank you. Thank you, sir. Next,
Thank you.
Moving on, session 2.
Okay, I'll take leave. Thanks everyone for this.
Okay, sir. Thank you, sir.
Sir, next session we can start at 11:20. Yeah, 11:30 is actual time.
Okay, okay.
So 11:20 we may bring up our resource person and start.
Okay, okay, Surendra.